This is the second part for Lesson 11.2, Congruence Tests for Triangles. In the previous video, we talked about the three tests for congruent triangles that are postulates. So we talked about side, 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 and angle, side, angle. And so we're going to use those now to learn how to use that to prove triangles are congruent. Okay, so the first thing we're going to do is we're going to look at sets of triangles and we're going to decide which test. So we have the three to choose from. Which of those will prove that the two triangles are congruent? If we don't have the right information, and so if we can't prove that that the two triangles are congruent with those three tests, then we're going to write NEI for not enough information. We're not saying they're not congruent, we just don't have enough to prove it. So looking at number one, we can see that we have this side is congruent to this side. So it looks like I'm looking at this triangle versus this triangle. And so I've got those two sides, and then I've got these two sides. And so I've got a side and I've got a side. And so what else do we need? I don't have an angle. It doesn't say anything about the angles, and you cannot say, well, they look like they're the same. That's definitely not enough to prove it. But one thing I can say is I can say that DB, it's exactly the same as DB. It's the same as itself. And that's something that we call the reflexive property. Okay, if we say 5 is equal to 5, that's reflexive. It just says something is equal to itself. So in this case, DB is congruent to itself. And so we can say that because of that, we have the third side. So we can say side, side, side. Looking at number 2, we have this side. We have this side. We also have an angle, but look at the location of the angle. Okay, if you wrote side, side, angle, or the other way around, that is not one of our tests. And so I'm not saying that these are not congruent, but I do not have the information I need to be able to prove it, so I'm going to say NEI. Okay, number 3, I have got this angle that's double marked. I've got this angle, and in between those two, I have a side. So that's going to be my angle, side, angle. And so that's enough to prove that those two triangles are congruent. Looking at number 4, I have that side is congruent to that side. Side CB is congruent to YZ. And then this angle is in between. And it's in between because it's created by the two sides. And that's how I know it's included. And so that's enough to say side, angle, side will prove that those two triangles are congruent. Now the second part of the directions was to write a congruent statement. So for the ones that I was able to say that they're congruent, I need to write a statement. So on number 1, I'm going to say triangle ABD. Remember, I'm going to write them in alphabetical order. So ABD is congruent to, you cannot just write the second one in alphabetical order without any regard for anything. So you have to look at this and you have to say, okay, A goes with C. And then I did AB. And so if I folded these, they would match that up. So B and then D. Just so you know, it is not always the case that B will match with B or that D will match with D. Sometimes that doesn't happen. And so we'll see some examples like that later on. I don't have to do a congruent statement for number 2 because they were not congruent. For number 3, I'm going to say triangle ABC is congruent to, so I did angle A, and so that's going to match angle X because they both have the same marking. So triangle X, and then B has the same marking as Y, and so then Z. So that's my congruent statement. And then for number 4, if I say triangle ABC is congruent to triangle, so if I go from A to B, I'm noticing that that's the side that does not have a mark on it. So I'm going to come over here and it's either YX or XY. So then I'm going to look, if I go from A to B and then B to C, I'm going to the angle that has one mark. So if I go Y to X, then I can go to the angle that has one mark, but it's through this side. So that's not going to match. So if I go X to Y, then I'm going to go to the side that has, or the angle that has one mark, but it's through the side that has one mark also. So it's going to be X, Y, Z. So it's not always in alphabetical order. This time it is, but just be aware that it matters how you write your statement. And number 5, we are going to prove whether or not, so it might be true and it might not be true, triangle FGH is congruent to triangle TUV. And I'm telling you that we're going to use SAS, so we're going to use side, angle, side. And that's just because we're just starting out, so I'm giving you a little hint as to how we're going to go about doing this. Finding the missing parts is going to help me prove congruent. So that's just kind of another little hint there. And so what we want to do at the very beginning is let's take a look at our pictures and let's see what else can we find out. And that's just a good practice in geometry. Look at your diagram. If there's not a diagram, you should draw one. But look at your diagram and see, is there any other information that's left out that I can find? And so if I look at my two pictures, I notice in my two triangles, I have two sides and two angles in each of them. Now, before you get too carried away with stuff and you know it's like, oh, this is 11 and this is 11 and this is 8 and this is 8 and this is 61 and that's 61. So yay, look at what it says. It's got a side, and is the angle included? No, it's not included. So that's not going to work. So you can't get too excited with that. So what I have is I do have two sides, but if I was going to use these two sides, what angle do I have to use? I'd have to use the 44 degrees. If I use the same two sides over here, I'm going to have to use angle T. Well, I don't know angle T. So the first question is, can I find out what angle T is? And so find out what angle T is. So what do I know about triangles? I know that then the sum of the angles added together, so I'll just call it plus x, is going to equal 180. So I can solve that equation. So 180 is equal to 138 plus x. So I'm going to subtract 138, and so I'm going to have x is equal to 42. So that means that this is 42. Okay, so let's start with our statement. So it says side, so let's do the 11s first. So I'm going to say FH. I'm looking up here, it says FH, so I know I'm going to have to do TV, and that they are congruent. If I look at my picture, they're congruent. So FH is congruent to TV. Now, when you say congruent segments, you need to put the segment over the top like that. Now, I also know if I look at the sides that are labeled with an 8, I also know that they're congruent. So I'm going to come in here and I'm going to put that down here where I say that this should be a G. I'm not sure if yours is labeled or not. But anyway, I'm going to say FG is congruent to TU because it is. Okay, they're both 8. Now, the thing that I've left out is I've left out my angle right there. And if I look at what I'm trying to do, I'd have to say that angle F is congruent to angle T, if that's true. So angle F has to be congruent to angle T. But if you notice, we just got done saying it's not. So it's not congruent. So because it's not congruent, I would say that triangle FGH is not congruent to triangle TUV, because if they were, then all of their corresponding parts would have to be congruent. And because this is 42 and that's 44, and they're supposed to be going together, they're not. So not congruent. Okay, number 6. Again, prove whether or not triangle ABC is congruent to triangle MNO, and we're going to use side, side, side. So we need to find the length of the missing sides. So one thing I want you to notice right away is that we have right triangles. So what do you know about right triangles? So think back to when we learned about right triangles before, and we learned how to find a missing side. So if I know this is 7 and this is 24, how can I find that missing side? Looks like that should be C right there. How am I going to find that? So remember Pythagorean Theorem. So I said 7 squared plus 24 squared equals C squared. And so we use Pythagorean Theorem to do that. So go ahead and calculate that. So it's going to be 49 plus 576 equals C squared. And so that's going to be 625 equals C squared. Take the square root of both sides. And so C is equal to 25. And so I don't have a C equals, but I do have a B equals, and so that's 25. So just using Pythagorean Theorem. Later on, when we actually write out a whole proof, we're going to have to say, I know that that's 25 because of the Pythagorean Theorem. Now, if we say this is 25, it matches NM. So I actually know that AB, so AB right there, is going to be congruent to MN. So I can use that for one of my sides. So I can say AB is congruent to MN. That's true. Okay, and then if we look at other sides, I've got 7 and I've got 7. So I can say CB or BC, I guess, and NO. So BC is congruent to NO. Okay, and then for my third side, how do I find this one? Okay, so that's going to be 7 squared plus x squared equals 25 squared. So you might recognize that as what we just did. So you get x squared equals 576, and then you take the square root of both sides, and you get that this is 24. So I've got two sides that are 24, so I'm going to say AC is congruent to, and again, I'm looking at my congruent statement to help guide me here, AC is going to be congruent to MO. And so because all three of these are congruent, I'm going to say triangle ABC is congruent to triangle MNO, and we have to give a reason why, because of side, side, side. And that means because of the postulate side, 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 and what it says, that's the reason why they're congruent. Okay, number 7, prove whether or not triangle WXY is congruent to triangle LMN using side, side, side. So on the right, it says find the lengths of all the sides of both triangles and leave your answers as radicals. Okay, so let's go ahead. We can find this side, YX. I can find that really easily just by counting. So I'm going to come over here and look for, I see XY is 4, so I'm going to write that. So that was easy. I don't see any others that are easy like that. So what I'm going to do is I'm going to use the Pythagorean Theorem to do this. And so if I look at, I'm trying to find WX. So if I create this triangle here, so where this is 2 and this is 5, I'm going to have 2 squared plus 5 squared equals WY squared. So I'll just call it Y squared. So 4 plus 25 equals Y squared. So Y, which WY is what I'm talking about, it's the square root of 29. That's how long that is. Okay, so I have found that this is the square root of 29. This is 4. So let's look at this side. So WX, this, if I make my triangle, that's 2 and that's 5. So that's exactly the same as what I just found. So I wouldn't know that this one's square root of 29 also. Didn't mean to erase that part. Okay, so that's what I've got. So I know that that's an isosceles triangle because that meets the definition of it. So now let's look at the other triangle. So if I look at MN, let's create this triangle right here. So that's going to be a side 1 and a side 4. So I'm going to have 1 squared plus 4 squared equals MN. So I'll just say M squared. So 1 plus 16 equals M squared. So M squared equals 17. So this MN side is equal to the square root of 17. So right now I can see that I am already going to have a problem with this because none of the sides of this triangle are equal to square root of 17. So there's no way that these two triangles can be congruent. And so I already know that I'm going to be proving that they're not congruent. However, it does say to find the lengths of all the sides, so I need to continue and find all the lengths of all the sides to finish out this problem. So I'm going to go ahead and find this side. So that's I'm going to make this triangle. So that's 2 and then 1, 2, 3, 6. So I'm going to have, I'm going to have 2 squared plus 6 squared equals LM squared. So I'll say L squared. So 4 plus 36 equals L squared. So 40 is equal to L squared. And so LM is going to be square root 40, and it just says leave as radicals. I don't even need to simplify them. So square root 40. And then NL, again, just make your triangle. So this is 2, and then this is 5. I've already done that one up here when I did that. And so this is going to be square root 29. So if I would have done that one first, I might have thought, oh yeah, we're on our way. We're going to be able to do this. But then we find out soon enough that we can't. So what I'm going to say is, and notice that I've got these laid out for you. So here's what I want to see on this. I want you to say that WY is congruent to LN, because they are. But then as far as other sides, WX is not congruent to. And I'm going based on my congruent statement up here. So when I said WY, I said LN. And so if I say WX, I'm going to say LM. So it's not congruent to LM. And then for the other side, I'm going to use the XY. So I'm going to say XY is not congruent to. And then I'm going to put that with MN. And so what that does is that helps me think out the reason why they're not congruent. And the reason why that's going to be really important is because we're actually going to be doing some actual proofs. And in an actual proof, you have to have every single reason listed. You can't skip. You can't not say something because you don't want to write it all down. You have to write it all. So what we're going to say is we're going to say WXY is not congruent to triangle LMN. And it's because the all of the parts didn't match. So anyway, that's the reason why. Okay, number 8, prove whether or not triangle DEF is congruent to triangle LMN using angle, side, angle. So we're going to go for angle, a side that's included, and another angle. So let's look at what we have. We have 90 degrees. Okay, great. I've got 2 angles that are congruent to each other, so I know that angle D is congruent to angle L. So that's helpful because I could actually start out with that. So triangle D or angle D is congruent to angle L because they're both 90 degrees. So that's one of them. Now I need to have another angle. The problem is I've got the 28 and I've got the 62 and they don't match and they're not even in the same places. So what I need to do is I need to find what is this angle right here. What is this angle right here? I don't know, so I'm going to find out. So remember about the 180 degrees. So 180, if I take away 28 and I take away 90, whatever's left is going to be right there. So 180, take away 90 is 90, and then take away another 28, and it leaves me with 62 degrees. So this is going to be 62 degrees. And so the good news about that is that that matches right there. So I can say that angle F is congruent to angle N, and that's because they're both 62 degrees. So the only thing I have to do then is I have to get the side, but it has to be the included side. So it has to be the 33. So I have to show what this one is. So I know that FD is 33. Can I show that LN is 33? So again, think of Pythagorean Theorem. I've got leg, hypotenuse. So I'm going to say 56 squared plus x squared is equal to 65 squared. And I'm going to find what is x so that that's true. So 56 squared plus x squared equals 65 squared. And I'm going to subtract 3136 from both sides. So I'm going to have x squared is equal to 1089. And now I'm going to take the square root of both sides. And I get x is equal to 33. Okay, the good news is that that matches FD. So I can say that FD is congruent to, notice I said FD, so I'm going to have to say NL. So NL. And so because my angle matches, or my side matches, my angle matches, I can say triangle DEF is congruent to triangle LMN by angle, side, angle. And that's my answer, that's my conclusion. But all of the other stuff that I wrote down, that's my work. That's the reason why. When we get into doing actual proofs, we're going to be talking about how you organize that. Okay, number 9, prove whether or not triangle DEF is congruent to triangle GHF using side, angle, side. So I'm going to have you pause the video right now, and I want you to just go through and see what you can figure out. Can you figure out like what you should do here? And if you get stuck, then it's time to start the video again. If you are able to get through the whole thing, that's wonderful. Start the video and just make sure you did it right. So go ahead and pause the video and see how far you can get. Okay, the first thing you should have done, you just notice that we've got these two sides. So I'm going to say that EF is congruent to HF because they are. They're both marked that way. So I'm going to write EF is congruent to side HF. Okay, so that takes care of one of my sides. Then I've got DF and FG, and they're both marked the same. So they're the same. So that can be my other side. So I'm going to say DF is congruent to, it's going to be GF. And again, I'm looking at my congruent statements to help me figure out which way I should write that. Okay, now the other thing is I'm going to need an angle, and it has to be the angle that's included. It cannot be like some other angle. So I'm not interested in this angle over here. I am not interested in this angle over here. What I'm interested in is I'm interested in this angle because it's included in my two sides. I'm interested in this angle because it's included. So if you look at that picture, do you see something that reminds you of something we've talked about recently? You see how this is one line, and you see how this is another line, and you see how when they intersect, they create angles. This angle and this angle are the two we're interested in. Do you remember learning about vertical angles? And that they are congruent. And so that means that angle F is congruent to, so do I call that angle F? We don't want to say it is congruent to angle F because then it seems like we're talking about exactly the same angle. So here's another little mini lesson on this. This angle F that I've got marked right there, another name for it would be EFD. So EFD, or DFE, or angle F. I can't say angle F is congruent to angle F unless we're talking about exactly the same angle. So I'm going to have to say one of those two things. So I'm going to say angle EFD is congruent to, and so then in my other angle F, I'm going to say, I can't say angle F, so I'm going to have to say either GFH or HFG. And so the question is, which one of those is correct? So since I went EF, I'm going to go HF because they go together. Okay, so I've proven a side, I've proven an angle in the middle, and I've proven a side. And so I'm going to say triangle DEF is congruent to triangle GHF by side, angle, side. Okay, last, number 10. When you have things that you have to prove, often or usually in some way you're given some information. So you're either given a picture that's labeled, which is how we've gotten these other ones that we've done, or it might just be a statement. So I have here this picture, and that's important because I need to see how everything is laid out, but I'm also given some information. So I'm given that AE is congruent to BD. So I'm going to come over here on my picture, I'm going to mark that. So AE is congruent to BD, so I'm going to mark them with the same marking. And then AD is congruent to BC, so I'm going to come over here and I'm going to mark AD, not with the same one I just did, but I'll do 2 marks there. And then BC, same thing. And then just continuing on, AB is congruent to ED, which is also congruent to CD. Okay, so that all comes from that statement. Then I'm told that the measure of angle ADE, so that means from A to D to E, so that angle is 35 degrees. And then I'm also told that angle BDC, so from B to D to C, that is 77 degrees. So it says find the missing angles. So I need to find this angle, this one, this one, this one, this one, this one, this one. I need to find all of the other angles in the whole thing. And so I'm going to use what I have learned, okay? So the first thing, well, actually, I'm going to have you pause the video and just see if you can figure out like something. Can you come up with something that you could use here? So go ahead and pause and see if you can come up with something. Okay, what I'm hoping you came up with is I'm hoping you came up with the idea that this is going to be 180 degrees. If you take 35 plus 77 plus whatever this is going to equal 180. And so if you saw that, that's really great. If you didn't see it, you need to be looking harder. Okay, you need to be trying harder to see what it is that you're missing. And so we're going to solve that equation. So 35 plus 77, that's 112 plus x equals 180. I'm going to subtract 112 from both sides. And so I'm going to get x is equal to 68. And so this angle right here that I'm calling x, that's going to now be 68. Okay, now that we have that, now it comes down to what have we just been learning about. So I want you to look at this triangle and I want you to compare it to this triangle. I'll give you a hint. Don't look at the angles, look at the sides. What do you see? Do you see that we have a side and a side and a side? Those two triangles are congruent to each other. So I am going to say that triangle ADE is congruent to triangle. So if I say ADE, I'm going to have to say DAB. DAB, because that's what goes together. If I was to match up the two triangles, this angle right here is going to match up with that angle right there. This side's going to match with this side. So I have to make sure I get them matched up right. So because of my sides that and everything that I have matched up, so I erase that somehow, DAB. So because of that, let's look at what else we know then. So if angle D in this triangle is going to be equal to angle A in the other triangle, so this is going to be 68 degrees because this angle matches this angle. and this angle is going to match this angle, so B and E. I don't know what they are yet. I can find out. But another one I know is I know that this angle right here, 35, is going to have to match that one. So I'm going to go in here and put 35 right there. So 68 and 35, what is that third angle? So I'm going to say 180 minus 35 minus 68, and whatever's left over, that's what angle E is. So I get 77 degrees. So this angle is 77 degrees, as is this angle right here. Now to find the third triangle, you might be noticing by now, hey, this triangle is also the same exact triangle because of the sides, side, side, side. Those two triangles are the same. All three triangles are the same. So if this one's 77, great, got that one. So what does angle C match up with? It's kind of easy if you look at this triangle and this triangle right there. You can see pretty easily that C is going to be 35 degrees, and you can see that this is going to be 68 degrees. So just a puzzle, you have to find the one right piece, and the one right piece on this one was finding that these three angles add up to be 180 degrees.